The video you are about to watch will teach you the basics of configuring IPv6 addresses and implementing RIPng. So to illustrate this process, I have used Cisco's packet tracer program to create a network topology that's actually based loosely on the network structure of my dad's company, with a few elements that are added in that are going to help with this walkthrough. So as you can see, the company has three distinct networks: the main office, the operations center, and the secondary office, and these are all connected to a centralized router. This router is connected to an ISP router which is then connected to an outside server to illustrate the connectivity between these devices and the outside server and any outside server on the internet. As it stands right now, all of these devices are configured for IPv4 and have RIP enabled, so they're all able to connect to one another and send packets to one another, including to the ISP router and the outside server. So what is missing at the moment? Well, of course, that would be the IPv6 capabilities. So we are going to go ahead and add those in via three different methods. The first method we're going to do is to statically add IPv6 addresses to the interfaces on the router itself. Then we're going to use a process to manually create an IPv6 address using something called EUI64. And then lastly, we're going to dynamically configure most of these devices to generate their own IPv6 address using a technology known as SLAAC. So let's get started. Now, let's imagine that the company received the IP address 2001 ODB8 5766 with the /48 from their ISP. They're going to need to divide that into three separate subnets, one for each of the networks that they have. So what I've done right here is I've taken this network ID, kept it at the front of the IP address, and I added a subnet of 0001, 002, and 0003. What this has essentially done is it's created three separate networks that are all within this IPv6 address range allotted by the ISP. Adding a subnet adding a subnet like this allows us to take the first 64 bits of the network and have that represent the network, and have the last 64 bits represent the interface ID for each of the devices that we're going to have within each network. So because we're focusing right now on the routers, we're going to want to have that interface ID equal to 1. And we're going to want that because that is the proper procedure for configuring a gateway in both IPv4 and IPv6. So as you can see, I added a 1 here, a 1 here, and a 1 here. Now these three are all on separate subnets, so it's okay that they all have a 1. There's not going to be any kind of conflict. This particular IPv6 address corresponds to the gigabit Ethernet, which corresponds to the main office. This one is the gigabit Ethernet 0/1, which is the operations center, and this one is the gigabit Ethernet 02, which goes to the secondary office. So let's go ahead and get started with configuring those devices. So now that we know what IPv6 addresses we're going to statically configure to each interface of this router, let's go ahead and start the process. So I'm going to go ahead and click the router, and I'm already in the CLI, the command line. So let's press enter, just like it says, and we will want to write enable. I'm actually going to zoom in here to make it a little bit easier for us to read, okay? So hopefully that is a little bit more visible for you. Okay, so first thing we're going to want to do is we're going to want to write conf space t, and that's going to bring us into the configuration. First thing we want to do in the configuration is we want to essentially write what interface we're talking about. So I'm going to just start with interface 0/0. So I'm going to write interface gigabit Ethernet 0/0, and that is going to bring us into the configuration of that particular interface. So we're going to write IPv6 address, and now we're going to write that particular address, which is 2001 ODB8 5766 0001 1, and we need to include a /64 to indicate that the first 64 bits of that particular address are the network ID. And upon pressing enter, all we need to do is write exit, and we can get out of that particular interface. Now we're going to move on to the second interface, which we'll just write interface gigabit Ethernet 0, 1. Now, if you remember, this is the one that's going to be going down to the operation center. So that means we are going to write IPv6 address 2001 ODB8 5766 0002, because this is the second network that we're going to be using, and we'll make that 1 and a /64. Same thing, we'll write exit, and then we'll write one more. Oops, sorry about that. There we go. Write one more to represent the secondary office. 2001 ODB8 5766 0003 this time, 1 and 64. And with that configured, we have our router set up to be the gateway for those three networks. Now that we have configured the IPv6 interfaces on the router, we're going to need to start configuring some of the devices within the network. Now, we could go to each device and individually enter in the network ID, or I should say the network prefix, the subnet ID, and an interface ID that we either randomly generate or through a system create. I'm going to show you one of the ways to create a network ID through a system known as EUI64. So let's go ahead and take a look at that. The first thing I want to do is I want to look at this printer right here. This is the main office printer. So if we click this, let me go ahead and zoom in for you a little bit. We go to its interface and we see that it has a MAC address of this right here, and we're going to jump into the details about that in a second. Okay. All devices that are able to connect to the internet have a MAC address. A MAC address, it's a unique identifier that's burned into each device. It cannot be changed. So it's comprised of 12 hexadecimal characters that are arranged in 6 pairs. Here it doesn't show it that way, so let's go ahead and bring it into this document I created, and we'll take a look at it. Okay, so here is that same MAC address that was shown on the printer, written out in hexadecimal format, the MAC address format. So as you can see, there are 6 pairs comprising a total of 12 hexadecimal characters. So this is the MAC address of that main office printer, and we're going to take that MAC address and we're going to use it to create an IPv6 interface ID. So the first thing you want to do is you want to split the MAC address exactly in half. 6 characters on the left, 6 characters on the right. And the 6 characters on the left are what's known as the Organizational Unique Identifier, or the OUI. Basically, they're the company code, in a sense, for whatever company developed your internet-enabled device, in this case, the printer. And then the last 6 are randomly generated and unique to each particular device. And so in this case, we have 7A966D. So what you want to do is you want to take these 12 characters divided into 2 groups of 6 and convert them into binary. Now, there's a million ways to do this. The internet is a great resource for typing in a hexadecimal and getting out a binary. So we have the binary figures here and the binary figures here. Now, what's interesting is that we keep them split, and in the center, we add the binary equivalent of the hexadecimal characters F, 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 E, which is actually 1111, 1111, 1111, 1110. So that goes right in between the binary characters that correlate to these aspects of the MAC address. Then, right after that, you go to the 7th bit in the whole sequence, starting at the left. 1, 2, 3, 4, 5, 6, 7. That bit gets switched. If it's a 0, it turns into a 1. If it's a 1, it turns into a 0. In this case, if we look up here, we see we have a 0. So we're going to go ahead and turn that into a 1. All right, so what we do after that is we take a look at all of this binary and we convert that into hexadecimal format. The 4 zeros will become 0, this will become 2, so forth and so on. And I've written all of the equivalents down here. Then what we're going to do is we're going to group these into pairings of 4. There's a pairing of 4, there's a pairing of 4, and then there's another pairing of 4. And that will become the 64-bit network, or I should say 64-bit interface ID that we are going to be using for our IPv6 address, okay? So what we will do for this particular printer, seeing that it's on the main office subnet, we're going to go ahead and I'm just going to type in right now so you can take a look at what its entire IPv6 address will be. We're going to start with 2001 ODB8, and we're going to go 55670001, and we'll put a colon there. Okay, 0001 for the subnet, 2001 ODB8 5567 for the prefix, and then we're going to have the interface ID with these characters that we just generated, these hexadecimal characters that we just generated through the EUI64 process. Now let's go ahead and head to that computer and we'll put them in. So here we are at the main office printer. We are in the configuration page via the configuration page via packet tracer. So we see the MAC address that we just used up here, and now we are going to add in that IPv6 address we generated. So I'm going to go ahead and press paste, put that in there, and we're going to put a /64 because we need to alert packet tracer as to how many of these particular characters of the IPv6 address, or how many bits I should say of the IPv6 address are the prefix. So we'll leave that right there and we will close that. So that process, while cool and neat and able or capable of generating unique address, is not the most time efficient way of doing it because it does require calculations and kind of requires writing everything out a little bit. So what we need to do is we need to find out a way to get it so that all of these devices can be automatically configured to have that very same EUI64 process done without any manual configuration. And for that, we're going to need to turn to something known as SLAAC. Now that we've configured the IPv6 address for the main office printer, it's time for us to add IPv6 addresses to all of these other devices within these three networks. Now, the EUI64 process is kind of slow to do manually, so fortunately there's a way to do this a little bit faster and more efficiently. So this is a process known as SLAAC, or Stateless Address Auto-Configuration. So the way that SLAAC works is that it essentially allows any device to create their own IPv6 address without being given one from a DHCP server or having one manually configured whenever that device is powered on. So the way that the process works is it essentially let's imagine that this device here, MOPC, is turned on. It will send out what's known as a router solicitation, which basically says, hey, any routers that are connected on this network, I need some information in order for me to be able to generate my IPv6 address. And any router that is listening and is able to respond will send what's known as a router advertisement. That will have the prefix. It will have the prefix length. Here's the example of the prefix length. It will also have the router's own IPv6 address and include the default gateway information. You can even set it to include some other information as well. So it will send all of that information from the router down to the device itself. And once the device receives this, it's able to take that information there and then generate its own interface ID, kind of like we did with the EUI64 process. So once it generates its own one, it takes that interface ID, hooks it onto the prefix that it has received from the router, and there we go, it has its own IPv6 address. The last step is it sends out a message to all of its neighbors, all of the other devices that can hear it on the network, and it basically says, hey, does anyone else happen to have this particular address? This is what's known as a DAD, duplicate address detection. Most of the time, no devices will respond saying that they have the message, so that IPv6 address becomes official and can be used without any need for DHCP or manual configuration. In just a moment, we're going to go ahead and turn on auto configuration for all of these. But before we do that, I do just want to show one quick thing on the router, just so you can kind of see the information about these router advertisement messages. So I'm going to go ahead and click the router, press enter here, type enable, and I'm going to type show IPv6 interface gigabit Ethernet 00. And this is the one that's connected to the main office. And I'm going to zoom in before I press enter there so you can kind of see what I just typed. So once you type that in and you press enter, it will give you a string of messages that show not only its global unicast address, but also these messages down here. Router advertisements are sent out every 200 seconds. And so what that essentially means is that every 200 seconds, the router will send out all of that information to any device that might be listening so they could configure their own IPv6 address. Okay, so we are now going to turn on auto configuration for all of the devices found in all of these networks. So as we go through this process, remember that every time I click auto configuration on these particular devices, they are sending a router solicitation to the router, which is then responding with the critical information it needs to create its own IPv6 address. And after I turn on the auto configuration for all these devices, we'll go ahead and take a look at one of them in particular and see exactly where that information goes and how it was able to configure that ID. So let's start with the process here. And I'm just going to zoom in, or I'm going to zoom out a little bit because it's just a simple process of clicking auto config for each one. So as you're doing this, remember the router solicitation is heading to the router and the routers are responding with that router advertisement containing the prefix ID, the router's own IPv6 address to use as the default gateway, and some other information if you'd like to calibrate that. So I'm going to skip the main office printer since we already configured that particular one, but I'm almost done here going through this entire process. Oh, whoops. Going through this entire process, and there we go. Now they are all configured to receive their own IP or to receive their own prefix and prefix length information as well as the default gateway and then generate their own IPv6 address. So let's just take a look at one of the particular devices. We'll zoom in on it and we'll see what happened by pressing the auto config button. First of all, as you remember me saying, in the router advertisement is the IPv6 gateway, and that is the router's own IPv6 address that will act as the gateway. So we have that generated right there. And then we also have an IPv6 address that has been generated as well. It's found the network prefix or the prefix length from the router advertisement, and it has also found the prefix itself. Now, it won't let us see this entire thing, but rest assured it is the exact same address or exact same prefix that or prefix and subnet, excuse me, that the router has. The one thing for us to take a look at though, just to see kind of how this process was made, how it generated this interface ID, is if we look, we see the telltale sign that it did in fact use EUI64, and that is an FFFE located right in the middle of the interface ID. Every time you do an auto configuration via packet tracer, it will use that. Sometimes on routers themselves, you can adjust that so that it is random. But in this case, it will use the EUI64, the very same thing that we did with the main office printer. So I'm going to go ahead and close that, and let's see if we can verify some connectivity. All right, so now that we have SLAAC completed for all of these devices and they've all been auto-configured, it's time to test just to make sure that there is that connectivity between the different networks attached to this particular router. So let's go to this laptop in the corner here. We'll go to Command Prompt, and I've actually saved the IP addresses, excuse me there, saved the IP addresses of 3 different computers located within the network, one in each one of the networks. So that should help us determine that we're in fact able to connect to these devices that have been auto-configured. So the first one I'll do is just my own route, or just the laptop's own router interface, and that's its own default gateway. So here we go, and we see we have a successful ping. The next thing we're going to do is we're going to actually ping this laptop down here, and there we go. Notice we're on the second subnet there. Notice the characteristic FFFE from the EUI 64 auto configuration, and there we go. We're able to get connectivity there. And last, we're going to go look at this one from the third network. Oh, guess not. I'll just go ahead and type it in here. All right, so we'll type that 2D0 58FF FE 48A2 720. And that is actually the IP address of this PC right here. So here we go, and we get the responses back. So all of the computers on all of the networks are able to um, send ping request or pings to one another and are able to receive data from one another. So now as the last step, we just need to configure the RIPng, the last stage here, to get it so that we can connect to the outside server and the ISP's router. Okay, so here we are on the final step, which is where we are going to enable RIPng routing, which is RIP next gen routing for the three networks here, which will ensure that they are able to communicate with this outside server. So as it stands right now, they're all able to connect to one another via IPv4 and IPv6, but we need to set up some dynamic routing in order to get it so that they are able to connect through this router, through the ISP router, all the way to this outside server. So let's jump right in here. I'm going to zoom in with the magnifier, and we are here on the SEM router. So the first thing you want to do, and by this stage you will have already done this, but you'll want to press return, type enable, and you'll want to make sure that you get into the global configuration and type IPv6 unicast routing. Now, I've already done that, or else a lot of this stuff would not have worked earlier, but make sure that's there, because without that command being entered in, you won't be able to enact the RIP process. So first thing we need to do is we need to type out the interface that we want to configure RIP for. And in this case, we're going to just start with the first one, gigabit Ethernet 00. And we'll get into the configuration for that particular interface. And all you need to type, very simple here, IPv6 RIP process 1 in all caps enable. And once you've done that, the process should be enabled. Type no shutdown and then type exit. And there we go. We have that interface up and running. Now we need to go to the next step, which is going to be to go to the second interface and kind of just repeat the process. So this will be interface gigabit Ethernet 01. Get us to that interface, IPv6 RIP process 1 enable, no shutdown, exit. All right. Next, we need to go to the final interface, which is going to be gigabit Ethernet 02 IPv6 RIP process 1 enable, and type no shutdown, and that's it. Type end. Okay, so we have that configured. Let's go ahead and give it a whirl. So before we begin the final process of checking to make sure that all of these devices are able to connect to the outside server now that RIPng has been configured, I did skip one step in the video, and the one step is very simple, but I essentially skipped the steps where I configure RIPng between the SEM router, the ISP router, and the outside server. So definitely make sure you do that. The process is not any more complicated than what you saw when we configured it, RIPng for the three interfaces on this particular router, but just go ahead and make sure that you do that if you're going to be connecting to some kind of outside router, or else the routing process will not work. So let's just choose one of the devices in one of our networks, and let's verify that it can in fact reach this outside server. So let's click the outside server here, and I'm going to go right to its Ethernet port. And I actually went ahead and put in a static IPv6 address for this. So I'm going to go ahead and press copy. And let's see if any of our devices are able to ping this particular outside server. So let's just go from maybe this smartphone here, go into the command prompt, and I'll say ping, and let's paste it in there. Oh, sure enough, it's able to receive information back, receive data back. That connection is sound. Okay, let's go to this laptop. Let's check this out. Go back into the desktop and I'll go ping. And let's just paste it. There we go. Receive that ping reply. And lastly, I guess we'll go from this server over here. Oh, whoops, server over here. And backspace that and type in this. And there we go. So one device, or at least one device from all of the different networks are able to reach that outside server now that RIPng has been configured. So over the course of this video, you've learned how to manually, or I should say, you learned how to statically enter an IPv6 address on your router using the CLI commands, or CLI interface, I should say. You've also learned how to manually do the EUI64 process to generate a IPv6 address for a host. And you've also seen how SLAAC, the stateless address auto configuration, can allow a device to create its own IPv6 address. So hopefully that has been able to help you out a little bit. And as an added bonus, I also showed you a little bit about RIPng and how you can get it so that networks can connect to other computers that are on net or are not connected directly to their router. I hope you enjoyed the video and feel free to add some comments to the video below. Thank you.